So we start. Good evening. I am Paolo. I'm head of preparation of Moon Solution. And today we talk about the new tool of Rayleigh application developed by Moon Solution. So we start 1 second. Okay. Yes. So good evening, and let's talk about the monitoring of railway infrastructure and this new tool. Let's start with why we made a new tool for the rail and what do we need to monitor with talk about railways. Okay, one of the prerogatives of rail transport is indubitably the energy saving due to the low resistance to advance of vehicles thanks to the low friction between rail and train. Therefore, in the face of a lower energy expended to keep a mass in motion, the lower adhesion become a problem when you have to stop the train. There is less control by the user. For example, with a car that you drive every day, if you brake when you see the obstacle, you avoid the collision almost always. The typical stopping areas for a passenger car, for example, are 6 meters at the speed of 30 kilometers per hour and 96 meters at the speed of 120 kilometers per hour. In case of weight background, for example, this distance increases, but they still remain within the distance of visibility. That is a distance that allows you to see the obstacle ahead and stop it safely. In case of train, the space increase considerably, and therefore, taking into consideration the more restrictive value, there will be 60 meters at 30 kilometers per hour and 960 meters at 120 kilometers per hour. A few meters must be added to this result for the technical intervention time of brake, which more or less 3 seconds, thus reaching a value of around 1020 millimeters, which can be identified how the standard stopping distance for a normal train, a passenger train. Okay, yeah. So for this reason, it's important that the railway line is always monitored. The geometrical parameters must be kept under control, both for a question of comfort, but above all for a question of safety. For this reason, they need us to create only one tool for monitoring the railway. The tool is integrated on our cloud platform, and we allow you to easily analyze and monitor the railway track. Also, following the MOVE philosophy, we use smart sensor, wireless and synchronized sensor, optimized especially for railway application. To obtain smart data, the MOVE platform allows you to monitor and analyze the railway better and faster only one place. That makes the whole monitoring experience smart, a complete solution for remote, real-time, and 24/7 monitoring of any railway. There are many parameters to monitor in the railway track, but certainly the most important parameters of interest for railway monitoring are Cant, twist, vertical deflection, and temperature monitoring. We can monitor all these parameters with move triaxial tilt meter, which we have been able to update with an improved version, adapting for the rail application with the version View 2. The tool also worked very well with the version 1 tilt meter. With the version 2 of the tilt meter, some features have been implemented, such as the synchronization to 1 second and the purification of anomaly data, which make the measurement very stable. But let's see how we talk of structuring the tool, with how we developed the tool. The first part are the setting and the monitoring section. The relay line extends for kilometers and kilometers. Often it's not necessary to monitor the entire route, the entire track, but only some specific area of interest. On the tool, it will be possible for the same relay line to create different monitoring sections. For each section, it will be possible to associate one or more sensors that we have to monitor for each area the parameter of interest. The configuration of the section, the positioning of the sensor on the section has been made very simple and intuitive by following the step-by-step guide. The configuration part is fundamental in the tool for a correct analysis and monitoring. Once the section has been configured and the sensor positioning, what we will see for each monitoring section? Space and time. We monitor 3 different parameters: vertical settlement, Cant, and twist. For Cant and twist, we have decided to monitor these 2 parameters with 2 different but extremely important graphs. One graph in space and one in time. The first graph in space is fundamental importance to have the overall behavior of the entire section under control. In this graph, in fact, we have on the horizontal axis the sensor or pair of sensor sequentially ordered how configured in the setting part of the section. On the vertical axis, we have the measured value for that event. Do we see an anomalous sensor value in the graph? Okay, no problem. You can immediately require to associate it spatially in the section in the first time, and you have the possibility to see its behavior over the time and what happened. In fact, the second graph is in the time domain. So for quantities, you can see the trend not only in the space, but also in the time. I can select a sensor and see for that specific sensor its trend over the time with the temperature connects. This reasoning and method has been implemented for the Cant. The Cant is the transversal slope of the track and is defined how the difference in height between the 2 rails measured normally on the track. With a single tilt meter, it's possible to obtain this parameter. And therefore, we Cant in space domain with the various sensors on the horizontal axis, while the Cant value is measured for each event on the vertical axis. and Cant in time domain. For each sensor, it's possible to see the trend of the Cant in the time. You select a sensor in this part, and you can see for a data range the trend of the Cant in the time. And also, and of course, the temperature. Very important to understand the effect they may have on the railway track. The other parameter is the twist. In the same way, the twist was implemented. The algebraic difference between two transversal levels, two Cant, taken separately at predefined distance, from 2 meters to 20 meters. The twist is the most delicate quantity for the stability of the union between the train and the track, often the cause of the train deviation from the track. We need to use 2 meter on 2 separate sleepers to get this parameter. And therefore, we have the twist in the space domain with the various pair of sensors on the horizontal axis and in the vertical axis, the twist value measured for each event that I can select from the list. Twist in time domain for each pair of sensors is possible to see the trend of the twist in the time and the correlation between the temperature and the twist. The other monetary parameter is the vertical settlement. The tool is based on the use of a beam. By placing our tip meter sensor on a metal beam of 1, 2, 3 meters, it's possible to discretize, split a certain length. The tip beam allows, if placing change, to monitor not only the distortion, but also the vertical displacement of the track and reconstruct its spatial trend with a broken line. Starting from an initial point 0, it's possible to reconstruct the deformation of any structure. For each anchor point, we have a displacement. It is possible to create different chains for each section and monitoring the vertical behavior of the railway track. This is more or less the configuration of deflection of a chain of the meter. This was introducing a webinar on the new release of the new tool that will allow you to fully monitor the overall behavior of the railway track. Easy and easy to understand. The tool will be released next Monday, and next week, I think Friday, you will receive a tutorial for the system configuration, for the configuration of the section, and a demo platform where you will have the opportunity to play with this new tool in order to become familiar with this new tool. Naturally, a small fee, more than the user annual fee, will be required to use this tool. And we organize another tool only with the partner dealer, another more application webinar with more data probably at the end of November. Thank you for your attention. And if you have some question, ask me, or see you next time. Thanks to you, Ben. Okay. 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 We have a question. How big are the sensors? So the bigger the sensor is, the same tilt meter, the same box of tilt meter that you have. So for this, no change in the length and the dimension of the sensor. So is the same. Okay. Okay. Perfect. I have another question in the chat. I have another question in the chat, and I answered to you, Park Adams, in private. So thank you for your time, and see you next time for the next webinar, more in detail for this tool, for using this tool. Thank you too much. See you.